Okay, Assalamualaikum. Alright, today we proceed with the approximation of the binomial distribution by a Poisson distribution. Previous lesson, you have learned how to determine the situation for Poisson distribution and how to find the probability if a variable comes from Poisson distribution. Okay, as you know, untuk Poisson, kita ada dua condition, whether period of time, the variable occur in the period of time ataupun in a certain region. Kan? Okay, so sekarang ni kita nak tengok approximation daripada binomial kepada Poisson. Okay, actually that variable belong to the binomial distribution scenario, but in a certain condition, that variable the binomial distribution can be approximate kepada Poisson distribution. Okay, so because of binomial dan juga Poisson, both of these adalah discrete random variable, so no need for us to make the correction. Okay, so nanti kalau ada kalau ada approximation daripada discrete kepada continuous, kena buat correction. But for this, tak perlu buat correction. Just you kena tahu the condition, why ataupun how ataupun when we can approximate daripada binomial situation kepada Poisson. Okay, so we read here. Okay, so dia kata kat sini, although the Poisson usually find applications in space and time problems, kan, ada dua, time within the period of time ataupun in a region, the space. Okay, it can be viewed as a limiting form of the binomial distribution. Okay, in case of the binomial, if n is quite large and p is small, okay, n is large. Okay, kalau situation binomial kan, you punya parameternya adalah probability of success dan juga number sample space n kan. Okay, if the n is large and p is small, the condition begins to simulate the continuous space or time implication of the Poisson process. Okay, allowing the parameter p is close to 0, which is small lah. Okay, the p is small, is close to 0, relates to the principal tree of the Poisson process. Indeed, if n is large, okay, and p is close to 0, then the Poisson distribution can be used. Okay, if our variable, first of all, is belong to the binomial distribution, okay, and then we see that the sample size involved is quite large. How large is large adalah when n is more than 30. Okay, when n is more than 30. And p is close to 0. 0.001, 0.005, 0.05 and close to 0. And n is large, kena kedua-duanya n. And the Poisson distribution can be used. Kalau nak gunakan Poisson distribution, kan kita punya okay, I tulis dulu untuk binomial. Binomial parameternya n dan p. Tapi untuk Poisson, okay, I tulis kat sini bila n more than 30, okay, p close to 0, then binomial tadi akan approximate kepada Poisson. Okay, so Poisson adalah, kan, parameter untuk Poisson adalah lambda ataupun its mean, right? Okay, so sekarang kita kena dapatkan value mean kat sini untuk nak guna Poisson distribution. So we need the parameter for Poisson, which is it is the mean. Okay, this the mean, notationnya adalah lambda ataupun lambda t. Okay, so sekarang kena tahu dia punya mean kat sini. Okay, so mean, bila kita approximate daripada binomial kepada Poisson, mean-nya adalah mean untuk binomial tadi, which is NP. Okay, which is NP. So maksudnya kena cari dulu mean untuk binomial to put ataupun to use in order to apply the Poisson distribution. Alright. Okay. So kalau mengikut teorem ni lah, teoremnya mengatakan okay, when n is very large, okay, approximate to infinity, and p is close to 0, very small, then mu-nya will be np. Okay, so kita approximate daripada binomial kepada Poisson with mean mu. Right? Okay, with this condition tadilah when n is large and p close to 0. Okay, so we look at the example. In a certain industrial facility, accidents occur infrequently. It is known that the probability of an accident of any given day is 0.05. Probability that accident on a given day adalah 0.05 and the accidents are independent of each other. So from the statement here, kita tahu the variable-nya adalah number of accident. Number of accident. So dia punya probability adalah 0.005. What is the probability that in any given period of 400 days, okay, so n adalah 400. There will be an accident on one day. Nak cari probability number of accident, nak cari probability of x, okay, of one day. So from here, we can know that from the penceritaan di sini, kita tahu yang x ni actually adalah from binomial distribution with parameternya 400 dan p 0.005. Probability of success number of accidents. Okay. Okay, but soalannya nak cari probability of x equal to 1. Okay. Probability it will be an accident on one day. So probability of x equal to 1. To find this probability, we should know the distribution for the random variable x. Okay, so from the story here, we know that x adalah binomial. But because of n is large, okay, conditionnya because of n is large, n is more than 30, and p is very small. Okay, p is very small, which is close to 0. So because of that, we consider to approximate this distribution kepada Poisson. So now our random variable x actually adalah can be distributed as Poisson distribution with parameternya adalah lambda, which is n darab dengan p. So, n darab dengan p adalah np, which is 400 multiply dengan 0.005, which is 2, right? Okay, the answer is 2. So, now our variable adalah Poisson 2. So we will use this distribution to find the probability of x equal to 1. So we will use so jawapan kat sini digunakan function untuk Poisson. Okay, it's up to you lah whether nak guna table ataupun you nak calculate manually. Okay, so kalau nak cari probability of x equal to 1, it's easy for you to calculate manually saja. Okay, yang kedua, what is the probability that there are at most 3 days with an accident? At most 3 days, so paling banyak 3, so 3 ke bawah, probability of x less than or equal to 3. So sama ada kalau you nak kira manually, so you kena cari probability of x equal to 0, 1, 2, dan juga 3. Okay. Kena calculate manually one by one, masukkan dalam function Poisson. Ataupun you can gunakan table. Macam biasalah gunakan table Poisson. Bukan gunakan table binomial, but now kena gunakan table Poisson sebab we already decide that this variable belong to Poisson distribution. Okay, so kalau yang this one dia gunakan table belakang lah. Table belakang adalah table less than equal. So kat sini terus boleh ambil when mu is 2. Okay, kalau tengok table belakang when m is 2, your r is 3 tadi. So the answer is 0.8571. Okay, ataupun boleh gunakan table more than or equal yang saya bagi tu pun boleh, tak ada masalah. Jawapan akan sama. Kita tengok the other example. In a manufacturing process where glass products are made, defect on bubbles occur, occasionally rendering the place undesirable for marketing. It is known that on average, 1 in every 1,000 of these items produced has 1 or more bubbles. What is the probability that a random sample of 8,000 will yield fewer than 7 items processing bubbles? So, the variable kat sini actually adalah number of bubble produced. Okay, number of bubble produced ataupun defect lah. Okay, so dia punya distribution actually adalah binomial, kan? Sebab dia bagi you n-nya 8,000 dan probability of this item produce 1 or more bubbles ataupun defect adalah 1 every 1,000, which is 0.001. Okay, so kita boleh tulis kat sini n-nya 8,000, p-nya 0.001. Okay, so because of the conditionnya adalah when n is large. Bila you tengok je n is large, n is more than 30 dan p is small. Okay, bila n is large je, you kena approximate lah. Sama ada approximate kepada Poisson ataupun approximate kepada normal satu lagi nanti. So, itu condition bila n is large. N daripada binomial distribution is large, so kita kena approximate. Okay, so now because of p is small, so we need to approximate kepada Poisson distribution. Poisson with mean-nya n, which is 8,000, darab dengan p 0.001, which is the mean-nya adalah 8. Okay, which is this. Okay, mean-nya adalah 8. So, kita akan gunakan distribution Poisson with 8 parameter. Soalannya, dia nak dapatkan probability that a random sample of 8,000 will yield fewer than 7 items possessing bubbles. Maksudnya, 7 items yang defect. Okay, so nak cari probability of x fewer than 7, x less than 7. So, sama ada you boleh gunakan table Poisson. Sekarang gunakan table Poisson, not binomial. Sebab kita dah approximate kepada Poisson. So, you boleh dapatkan. Kalau nak guna table less than or equal to 6 lah. Sama dengan less than 7. Kalau nak gunakan table more than, it will be 1 minus probability of x more than or equal to 7. Right? Sebab dia nak 6 ke bawah. So, 1 tolak 7 ke atas. Okay, so boleh guna kedua-dua lah. Sama ada gunakan table less than ataupun more than. So, kat sini saya letak, saya ambil just daripada table ni je. Dari textbook ni. Table less than. So, kita ambil tadi. Mu-nya 8. Then, R-nya 6 tadi kan. So, the answer will be 0.3134. Okay, so this is the answer. Okay, so that is the condition and situation. How you ataupun how or why you approximate daripada binomial distribution kepada Poisson distribution. Alright.